Welcome, everybody. My name is Jordi Ricard, and it's a pleasure to introduce the second session of our Journey to the Cloud series after the initial session 2 weeks ago about Microsoft Azure Synapse. Today is a turn for Google Cloud Platform, so let's get started. With that, it's my pleasure to hand over the session to Oscar Martinez, head of our Big Data and Cloud practice. Oscar, can you share the highlights of this series of webinars we are preparing?
Thanks, Jordi. So today is the second session of our Journey to the Cloud series. In the first session that we did a couple of weeks ago, Manuel explained basically how to build a data lakehouse on Azure using Synapse as the cornerstone of the platform. We have every year more and more customers wanting to run their data platform workloads on Google Cloud. Today we're actually gonna be talking about one of the cases. There are a bunch of very interesting services in that platform, but I don't want to spoil about Google Cloud because that will be something that my colleague Victor will be covering in just a couple of minutes. So that's the today's session about Google Cloud. We already have scheduled a third session about Amazon Web Service and the whole plethora of services that you can find in that big box of Amazon. And we already scheduled this Amazon webinar for September after the summer. So be sure to register for that one if you want to learn more about Amazon and how we use it to build a very interesting platform for one of our other customers. Then we are also seriously considering to do other webinar series on other prominent data platform technologies on the cloud, namely Snowflake, Dremio, and Cloudera. And we might add Oracle if time permits. These other webinars, Snowflake, Dremio, Cloudera, and Oracle, might be scheduled for later this year in the Q4 or maybe even 2023 next year. But let's see. So without further ado, I will give you the control, Victor, so you can explain to the audience what Google Cloud can do for them. All yours, Victor.
Thank you, Oscar, for the introduction. So I'll do first a quick overview of the Google Cloud services. So as Oscar said, Google Cloud is one of the top 3 main public clouds. It was the latest one of the 2 that he said, the Amazon and Azure. This one was released in 2008. And currently, Google Cloud has more than 150 services that it comprehends compute, storage, big data and data analytics, AI and machine learning, among other services like logging or networking. In this section, in the following slides, we're going to delve in deeper in some of the main services that can be used to create a data platform in Google Cloud. I'm going to start with cloud storage, which is basically the data lake in Google Cloud. It's, in short, an unlimited object storage that automatically manages replication across regions for you. Here, you pay only for what you use. In this case, you're paying only the amount of bytes that you are storing. However, cloud storage provides these lifecycle policies that change the type of storage of your data, having like a balance between the cost of the storage and the cost of the retrieval of the data. Specifically, there are 4 types. The first one is the standard, that is like the default type, which is the most expensive storage, but it's the cheapest retrieval, and it's used for the data that is accessed in a daily basis. Then there's the nearline, which is less expensive storage, but more expensive retrieval. It's thought for infrequently accessed data, usually for data that is accessed once a month. Then the cold line, that is also cheaper storage and more expensive retrieval in comparison with the nearline. And it's for the data that is accessed once per trimester, for example, to retrieve some backups or something like this. And then there's the archive, which has the cheapest storage, but is the most expensive retrieval. So it's basically thought for this historical data that you won't access, or maybe you access 1 year later or so on. So having good lifecycle policies will help you reduce costs in your billing at the end of the month. Then I'm going to talk about BigQuery, which is one of the most, if not the most important services in Google Cloud. It's a serverless data warehouse that allows you to create internet tables, which basically relies on Google Cloud's distributed storage, the distributed storage called Colossus, that handles the replication distribution automatically for you. But you can also define external tables, which can point, for example, to the cloud storage to execute SQL on top of your files, or you can even point to external services from other clouds, becoming like this a multi-cloud data warehouse. You can build and train machine models with SQL also in BigQuery. It also provides natively geospatial operation for analysis, where you can create geometric figures like points, lines, and so on, and do operations like intersect, or if it's pointing inside a circle, etc. So this is a serverless service. There is no cluster to pay, so you don't have to worry about RAM or capacity or so on. You just pay for the queries you do depending on the amount of bytes processed. Of course, when you hear this, it can be dangerous because you can run really expensive queries. However, BigQuery provides these quotas to limit the cost. For example, you can limit the amount of gigabytes of each query or the amount of gigabytes a user can spend for every day. Also, another way to reduce costs while using BigQuery is using the reservations, which allows you to reserve some compute pool capacities to have a flat rate pricing rather than only a on-demand pricing for your queries. And furthermore, you can mix these types of plans so you can choose the better that fits your needs. And well, finally, BigQuery also has this set of views that are called information schemas, where you can track things like the queries that are run by your users, how many bytes does this query process, or how much cost a specific query. They are really useful, but the bad thing is that they only track the last 6 months of data. Then we have Cloud Functions, for example. It's a serverless function as a service where you can code scripts in the most common coding languages like Node, Python, Go, Java, .NET, Ruby, or PHP. And as it is serverless, you just have to pay for the time it is executing. So there is no need to have like a server running and waiting for the petitions to come. You just execute this code whenever it's necessary. However, there is a maximum execution duration of 9 minutes, so you have to properly design your scripts. Then there's the PubSub, which is the asynchronous messaging service, which is based in the publish-subscribe architecture, where you basically have like a receipt where you receive messages from HTTP calls or other Google Cloud services, for example. And you have also some listeners that are triggered when this message arrives. And these are services that like Dataflow or Cloud Functions. And here you only pay for the bytes that are stored in PubSub in the service. And the last service I'm going to introduce is Data Studio, which is the visualization tool that you use to create dashboards and reports in Google Clouds. It can connect to multiple services, not only from Google Cloud, but from other services in Google, like Google Ads or YouTube, and also files like spreadsheets. Into the studio, users have their own workspace to design and develop their dashboards, and they also have the ability to share them with their colleagues in the company or even make it public. And the best thing of this service is that everything is free. So now I'm going to introduce you a customer project we did where we built a near real-time, completely serverless data platform. So this is like the diagram of the main process that is being carried out in the data platform. I know that this diagram can be quite messy. Don't worry, because I will explain it in the following slides. But to put you in context, our customer here was receiving every week many CSVs with thousands of rows and columns in S3 for different projects that they were carrying out. And our customer wanted to import this data into GCP, storing it in cloud storage and also in BigQuery to perform some analysis. So I will start explaining how we did to import this data from S3 to Google Cloud with this transfer service, which is the first box that you can see on the right of the Amazon S3. So this transfer service is basically a service that that allows creating some transfer jobs that import your data into cloud storage from other sources like S3 or ADLS in Azure with any code involved. In our case, we configure one transfer job for each project that we had to import all the data. So let's see how we did it. There are 5 steps to create a transfer job. The first one is to specify like the source, in this case was the AWS S3, and the destination, which is the cloud storage. Then the second step is basically specifying some details about the source, the S3 bucket and the credentials to access it, the AWS secret and the access keys. And then the third step is specifying the destination in the cloud storage, the bucket and the path. Then there's the fourth step, which is basically some extra configuration where you can choose what to do if you are trying to bring a file that is already there, if you want to overwrite it or not, or if you want to overwrite it only if the files have changed, which is the option that we take. And then the last step is the configuring the scheduling options that in our case we set it to be like to be run every day, as we don't exactly know in which day of the week we are going to receive the data. So focusing on the first main step, let's say, once we have the data in cloud storage through the transfer services, we configure the cloud storage to trigger a cloud function every time a new file is placed in cloud storage. This cloud function is the one that we call streaming, that I will explain in the following slide more in depth how it works. But in short, it's the responsible of inserting the data into BigQuery and also keep tracks of the status of each file, if it was inserted correctly or there was any issue on this process. And then, of course, when we have the data there in BigQuery, the analysts can create their tables, their visualizations with Data Studio or run whatever queries they want. So this is the diagram of the streaming function. Remember that the streaming function is triggered and runs for each file. So this is the full flow that all the files are going to do. The first step is basically to get or create a Firestore entry. This means that if we get a Firestore entry, it means that the entry already existed and we are trying to insert a data that already was there. So we are going to do like a duplication of the data. So as we don't want this, we could move it away and track it in the status that there was an attention of duplication. And if we create the Firestore entry, it means that it's a new record and we want to process this. So if we create the entry, we would go to the next step that would be setting a start timestamp. Then we could get the schema of the destination BigQuery table that we have it stored in a file in cloud storage. We will retrieve it here for creating later the external table. Then we download this file from the cloud storage into the function temporary file system, basically to read this file and get the header that we will use it to mix it with the BigQuery schema, with the original one to create the external table. And then we also will count the file, the rows that contains the file. So we will be able to compare how many rows it has the original file and how many rows are we inserted in BigQuery to see if there's any discrepancy. Then we will create the external table that points to this cloud storage file. And then we will execute the insert statement to insert from this external table into the real BigQuery table. Once the data is inserted, we remove the external table And finally, we set a success attribute, and we will store the duration of the entire process. As you can see here on the right, it's an example of the Firestore entry where we store like the file path, all the timestamps of each process that I've mentioned, the duration and the success if it was true or false, and the number of files or the number of lines in the file. So the second step of this process, as you can see here, it's on the bottom side. It's basically a cloud function that is called periodically with the cloud scheduler, that the cloud scheduler sends a message to the PubSub topic, and then the cloud function is triggered to perform this check-in operation that I will explain you obviously in the next slide. But it does some checks, and the result is stored in a cloud storage bucket. So this check-in function, what it does basically is first it determines like the current and last month, as we want to check the correctness of the data of these 2 months. And also we calculate like a 20 minutes frame, as executions being run recently might have not ended yet. And we might think it is an error, but in reality, it's that the process is still running and we have to wait for it. So for all the files, it is checking the cloud storage and in the Firestore and in BigQuery if there were any issues at all. And well, these issues are listed here on the right table, but we will go into it later. So basically, this checking function also applies some minor fixes that I will also explain you in this table. And then the results basically are CSV files that are stored in cloud storage, where we generate one CSV for each type of issue that we can find in this process. And the file, well, the CSV contains like the path of each file with issues in the cloud storage. And finally, we send an email to the administrator and the customer to notify about everything. So if we look at the right table right now, the different things that can happen, obviously, the first one is that everything goes okay. That's the most common case, no? But we have to handle all the possibilities. So the second possibility, the first issue that we can encounter, basically, is that there's like a discrepancy between the number of rows between the CSV in the cloud storage and the data inserted in the BigQuery. This means that there were some kind of errors while inserting. In this case, we should review the data and the schema. And if necessary, we could delete the inserted data and reload it with the streaming topic again, if necessary. Then there's the possibility that we have like a success in the Firestore, but the data is not actually in BigQuery. So this might mean that the data might be deleted from BigQuery. And the thing to fix this would be like deleting the entries in Firestore, so it will get reloaded again when retriggering the streaming function. Then the other possibility is that there's no entry at all in the Firestore and nor in the BigQuery. This means that the data has not been inserted at all. So basically, retriggering the streaming topic, it will try to insert the data and it will do it. Then there's the chance that there's an entry in the Firestore, but it doesn't have like the success and there's no data in BigQuery. Then it would mean that maybe the function end up unexpectedly. So we should check the logs and maybe retrigger a streaming topic that maybe the function works again in this case and the data is inserted. Then there's the possibility that this same thing happens, but this happens in this execution is being done in this 20 minutes frame that I mentioned before, which means that this execution is currently being done. So we should only wait until it completes. And there are two other cases that there is no entry in Firestore at all, but the data is in BigQuery, or the entry in the Firestore, it says that it was an error, but the data is in BigQuery. So these two possibilities are handled by the checking function, basically creating the Firestore entry properly. So the third and last step is, as you can see on the left, it consists of a Python script that we call the operations that can be executed in the Cloud Shell. It's basically a very handy script to fix the issues I mentioned before, that I'm going to go to the following slide so you will see how it is done. So basically, these operation files, what it expects is a CSV with the cloud storage path of each file with issues, which is basically the output of the checking function before. And you can do different operations. You can retrigger the streaming function, you can delete entries in Firestore or BigQuery, or you can delete the external tables if, for example, the cloud function finishes before destroying it. And we also added the possibility to preview the execution of this script, as it can be quite scary sometimes to delete data directly from your data warehouse. So you can visualize exactly what would do the function before running it. And here on the table on the right, if you can see, it's the same as before, but we have highlighted in blue the ones that, well, the issues that can be fixed using this operation script. So we have everything handled in this data platform. So in the second topic, we wanted to talk about quite concerning topic in big data and data platforms, which is basically the billing and the cost monitoring, because sometimes controlling the cost of your data platform can be very difficult. In this case, luckily, Google Cloud provides a capability to export your billing data into tables in BigQuery with really few clicks, which allows you to do directly queries to your tables to check your billing and your cost. Moreover, in BigQuery, you have the information schema views that I mentioned before, where you can track the cost of each query you're running. And also, we have to consider that this information schema only contains the 6 last months of data, as I said before. So what we did is we create a simple cloud function, as you can see in the diagram on the right, that is basically triggered every month by a cloud scheduler that copies this data of the information schema into another table in BigQuery. And additionally, we use the same function to store additional information like the amount of bytes stored in BigQuery and cloud storage. Here on the left side, you can see the tables that I am mentioning. The one that says export are the ones created automatically with the export capability of Google Cloud. And the other 3 are the ones that we are creating with the cloud function with this additional information. And well, finally, we wanted to show you this Data Studio dashboard, because basically Google Cloud not only provides these export tables with the billing data, because they also provide this dashboard, which is a template that you can connect to your billing data in your tables in BigQuery. And as you can see in the first image above, you can see things like the cost of the projects, the cost by teams, if you use the team tag, or the cost by every service, or the cost by environment, if you have the environment tag also. And of course, you can modify this template and add your visualizations, as we did to add this custom storage calculator that we do. So wrap up and conclusions. The main conclusion is that Google Cloud has all the services that you might need to build your data platform. As we showed in this webinar, you can create an entirely serverless data platform in Google Cloud. Also, a big remark is BigQuery, the information schema, allows you auditing at user level and query level. And then finally, Data Studio is a really powerful tool that allows you to create visualization that also provide the predefined billing template, and everything is free there. Well, remember that we have a blog in our website where you have available some blogs about Google Cloud and also other topics. If you're currently thinking about going into Google Cloud, or you need help to develop or manage your current Google Cloud data platform, please don't hesitate to contact us, and we are willing to help.
Thank you very much. It was a pleasure. Thank you, Victor. Thank you, Oscar, for the interesting session, and see you next time.